Okay, so back again, we're going to talk about angles. And if you notice up there on the screen, it says that angles can be measured in both radians and degrees. So the biggest thing we need to take from here is that there are two ways that we can measure angles. We can measure them in both radian form and degree form. And so if you look down here, here's the definition of radian measure. It states the measure theta in radians of a central angle of a circle is equal to the ratio of the length of the intercepted arc S to the radius of the circle. So what I need you to remember here is that theta equals S divided by R, where theta is measured in radians. And so if we look at our diagram here, we see that S is the outer part here, and we see that R is the radius. And so how I find a radian is I take the intercepted arc divided by the radius. And we will learn more about this formula when we talk about arc length and area of a sector. And so now what we need to do is be able to convert between the two. And so if you notice, we have some conversions below. And it says to convert degrees to radians, what we are going to do is we're going to multiply by pi over 180. Okay, so to convert from degrees to radians, we're going to multiply by pi over 180. Now we're going to convert radians to degrees. We're going to multiply by 180 divided by pi. Now this is going to look somewhat familiar because if you remember, once upon a time, if I gave you 5 centimeters, and so example, I gave you 5 centimeters and I told you I needed you to convert that to meters. Remember, what we would do is we would multiply that by, and here's where my conversion comes in. What I would do is I would write that 1 meter is equivalent to 100 centimeters. And so what we're going to do is we're going to go ahead and use that. Notice here the centimeters would cancel off. We're going to use that same idea when we go and convert from degrees to radians. And so just like 100 centimeters is equivalent to 1 meter, we know that 1 pi is equivalent to 180 degrees. Now when I say it's equivalent to, that means it's the same measure. And so let's go ahead and look at the following. It says to write each degree measure in radians as a multiple of pi. So we're converting degrees to radians. So in order to do that, I'm going to multiply by pi, and in this case radians, and I'm going to divide that by 180 degrees. And so if I look at that, I see that I can cancel off the degrees, which is exactly what I wanted to have happen. I wanted it to be in radian form. And then I'm going to look at the 120 and the 180, and I notice that they're both divisible by 60. 60 goes into 120 2 times, 60 goes into 180 3 times. So my answer is going to be 2 pi on the top over 3. And that is in radians. You don't need to put the RAD, it's just understood to be there, but you can if you want. So 120 degrees is equivalent to 2 pi over 3 radians. Now if I look on the next one, I've got negative 45 degrees. So I need to go ahead and convert that, so I'm going to go ahead and multiply that by pi radians over 180 degrees. And so I'm going to notice once again that the degrees cancel. And so then I have negative 45 pi over 180, but I also know that 45 goes into both. 45 goes into 45 one time, it goes into 184 times. And so I end up with negative pi over 4 radians. And that is your answer. So once again, negative pi over 4 is equivalent to negative 45 degrees. Now if you look at this one, it says to write each radian measure in degrees. And so what I'm going to do is flip what I was doing. I need to cancel out the radians, so I'm going to go ahead and multiply that by pi on the bottom, 180 degrees on the top. And if you notice, your pi's cancel. And so that leaves me with 5 times 180 degrees over 6. 6 goes into 180 30 times. So I end up with 5 times 30 degrees, which is 150 degrees. So that means that 150 degrees is the same measure as 5 pi over 6. If I look at the bottom one, 3 pi over 2, and that's a negative, by the way. I need to cancel that out, so I'm going to go ahead and multiply that by 180 degrees over pi. Now if we look here, I'm going to need to go ahead and cancel my pi's. I know that 2 goes into 180 degrees 90 times. And so my answer is negative 3 times 90, which is negative 270 degrees. So once again, that means that negative 3 pi over 2 radians is equivalent to negative 270 degrees. Now the very last thing we're going to talk about is coterminal angles for today. Now when I think of the prefix co, that means that they share something. Like co-captains on a team, they share the captain duties. And so terminal, if I think about that from the very first slide, I talked about terminal sides of angles. And so coterminal angles mean angles that share the same terminal side. Now notice they have to be in standard position. And the thing here is that they have to have different measures. So if I know that that's 120 degrees, I need to come up with another angle that shares that same terminal side, but it can't be 120 degrees. So I need you to think about that. I want you to think about what happens if I went backwards there. I'm still going to have the same terminal side, but my measure here is actually going to be negative 240 degrees. So that would be an example of two coterminal angles. Also, another thing I can do, I know that one revolution is 360 degrees. So if I went 360 and an additional 120, I have went a total of 480 degrees. So that is another coterminal angle. Now just a little tidbit, there's an infinite number of coterminal angles, and so what we need to do is be able to write that. And so what we're going to do is we're going to take whatever angle we have. So in this case it was 120 degrees. And I'm going to add or subtract one revolution, which in this case is 360 degrees. And I'm going to multiply it by n. So what multiplying it by n takes into account for is every possible angle I can get. And so now I need you to think about, since we're dealing with both degrees and radians, what would I do then if it was in radian form? Instead of 360, I'm going to use 2 times pi. So I'm going to take whatever angle I have in radian form and add or subtract 2 pi times n. Now just a little tidbit on your homework. If your angle is in degrees, I expect you to answer in degree form. If your problem is in radians, I expect you to answer in radians. And so we're going to look at an example of each of these. And so first of all, if you look at the following, it says find all angles that are coterminal with the given angle. Then find one positive and one negative angle coterminal with the given angle. So 45 degrees, what I'm going to do then is I'm going to add or subtract from the previous slide 360 degrees times n. So that means all angles. So that is your answer when it says all angles. Now what we need to do is find one positive and one negative angle. So here's the one positive, here's the one negative. So how we do that is I'm just going to take 45 degrees and I'm going to add 360 to that. Now when I do that, I'm going to get an answer of 405, and that's a positive 405 degrees. So there is one positive right away. In order to find the negative, instead of adding 360, I'm going to subtract 360. And if you notice, when I subtract those two, I get a negative 315. So there's my one positive, there's my one negative. Now what I'm going to do is move on and look at one that's in radian form. And if I look at this one that's in radian form, same instructions, except for now I've got negative pi over 3 in radian form. So I'm going to add or subtract, not 360, but really 2 pi times n. And there is your answer. Now what we need to do is find one positive angle. So to find one positive angle, I'm going to take negative pi over 3, and I'm going to add 2 pi. Now in order to do that, that might look kind of confusing. In order to do that, I'm going to take negative 1/3, and I'm going to add 2 to that. It's just a fraction, and so if you do that, you get 1 2/3, but we never answer in terms of a mixed number here. We're going to actually answer in terms of an improper fraction, which is 5 pi over 3. Okay. Now I'm going to do the same thing. Okay. I'm going to go ahead and take negative pi over 3 minus 2 pi, and that will go ahead and give me my negative angle. So what that means is I'm going to take negative 1/3, and I'm going to subtract 2. Okay. If I subtract those, I get negative 2 1/3, and that gives me negative 7 pi over 3 as my answer. Okay, and so there's one positive and one negative angle. So now, the very last thing today is going to be your assignment. It's found on pages 238 through 239, 2 through 26, the evens.